This is Sukriti Joshi. Our today's topic for this particular video session is Cannizzaro reaction and its applications. In organic chemistry and even in chemistry, certain name reactions plays a very important role. Now, what is the meaning of this name reactions? So when we have a particular kind of substrate, that substrate will follow a different type of organic reactions like addition reaction, substitution reaction, nucleophilic substitution, electrophilic substitution, same way elimination or any other kind of reaction. And at that time they forms a particular type of product. That particular reactions are considered as name reactions. This name reactions gives us specific products and they will give us that product in proper quantity. So in chemical reactions, in particular chemistry, we have this kind of name reactions. So one of them is Cannizzaro reaction. We will see here what is Cannizzaro reaction and what is the use of Cannizzaro reaction. What are the examples of Cannizzaro reaction and how it will be very helpful to us in various industries. So let's begin with Cannizzaro reaction. Cannizzaro reaction is an organic reaction of an aldehyde without active hydrogen that undergoes a redox reaction under the action of strong base. So they will give you, or they basically involves reaction of aldehyde, right? But here the aldehyde contains an inactive hydrogen group, or it's done without that active hydrogen. Generally, we have different types of hydrogens in our functional group. So this will be there in which we will use inactive one. Okay. So the history of this reaction goes back to 1895. So in 1895, when the Italian chemist named Stanislao Cannizzaro obtained benzaldehyde and benzyl alcohol by treating benzaldehyde with grass ash. So here he obtained benzene, which contains an aldehyde group on itself, and benzene, which contains an alcohol on it. So that becomes benzyl alcohol. So what he will use is basically he used grass ash. So he reacted grass ash with benzaldehyde. Examples of aldehydes which we can include here. It can be vanillin, it can be benzaldehyde, it can be syringelic aldehyde, it can be formaldehyde, etc. So we can use here any kind of aldehyde containing compound. We just have to make sure that our compound should contain HCHO, right? Or generally it should contain CHO, not formaldehyde. It's not required that it should contain formaldehyde, but it should at least contain aldehydic group. Okay. So here they undergo intramolecular and intermolecular oxidation reduction reactions under the action of strong base, which is NaOH, to form a molecule of carboxylic acid and a molecule of alcohol. So what it will form? It will form it will convert itself from CHO to COOH and OH, right? So in this manner, the conversion will be done in Cannizzaro reaction. Now, let's see how it is goes or how it will go. So what we will have here is basically aldehyde. So two parts of RCHO. R can be anything, it can be aryl, it can be alkyl group, etc. So that particular aldehyde functional group containing compound will be reacting with NaOH. So here NaOH is a strong base and H3O plus will be there. Now what will happen? The first compound that we will get is containing alcohol. Right? As you can see, RCOH and H. So RCHOH, that particular compound will be formed. Plus carboxylic acid. So R, C double bond O and OH. So it's basically carboxylic acid containing compound. Okay everyone? So one is OH containing compound, another one is carboxylic acid containing compound. So both of them are basically the formation from aldehydic group. Now let's see the Cannizzaro reaction examples, that how it will be formed and which kind of product we will get here. So when we use this, so we took two parts of benzaldehyde as you can see in the image. So benzene contains CHO group, will react with NaOH plus H3O plus. Now the first compound is there, which is benzyl alcohol. As you can see in the image, the first group is benzyl alcohol. The functional group which is present on it is alcohol plus benzoic acid. So benzene contains carboxylic acid functional group, right? So this is the first example in which we will convert benzaldehyde to benzyl alcohol and benzoic acid. Now let's move ahead to the next example. Our next example is formaldehyde. So what we will do here, we will take two parts of formaldehyde, which is HCHO. That two parts of formaldehyde will be reacted with NaOH and H3O plus. Now the first compound that we will get here is methanol and formic acid. So methanol, that is CH3OH, the first compound which is formed is CH3OH, while another compound which is formed is formic acid. So it's HCOOH. Okay, so it is basically also known as a reaction for conversion of formaldehyde to methanol and formic acid. Third one that we will have here is conversion of 2,2-dimethylpropanol. So here we will take two parts of 2,2-dimethylpropanol, reacts with NaOH and H3O plus was there. Now both of them contains or converted to 2,2-dimethyl-1-propanol plus 2,2-dimethylpropanoic acid. So as you can see that CHO group will be converted into OH group and C double H group, right? Now let's see the mechanism of Cannizzaro reaction. The reaction begins with hydroxide attack on the carbonyl carbon followed by deprotonation to give a dianion. Now the unstable dianion releases a hydride anion which attacks another molecule of aldehyde. In this process, the dianion converts to carboxylate anion and the aldehyde to an alkoxide. This particular alkoxide then picks up a proton from water to provide the final alcohol product. And at the same time, the carboxylate is converted to carboxylic acid product after the acid work up. So in general, we have to understand that oxidation and reduction mechanisms places here, or they plays a very important role. Okay, let's see how it goes. So nucleophilic attack on the carbonyl group was done to give an dianion. The That is the first step. So aldehyde, that OH minus group from NaOH will attack on the carbon which contains double bonded oxygen with it. So first of all, it will get converted into dianion, as you can see in the image. In second step, the conversion of dianion to carboxylate and another aldehyde molecule to an alkoxide ion was done. So here RC double bond or RCOOH, that is our dianion, will react with further one compound or one molecule of aldehyde containing compound. So that will basically gives you carboxylate, RCOO minus. That particular compound is carboxylate plus alkoxide was formed. Now in step number 3, protonation of the alkoxide to an alcohol and carboxylate to a carboxylic acid. So what will happen here? We have alkoxide reacts with water, forms alcohol, plus one hydroxide ion will be removed. Now when we have our carboxylate ion, that carboxylate ion's reduction will be there, one H will be added to it and it will convert itself into carboxylic acid, plus H2O will be removed. Now there are certain types of Cannizzaro reactions from which the first one is crossed Cannizzaro reaction. So if an aldehyde without any alpha hydrogen is made to react with formaldehyde in the presence of base to give formic acid and an alcohol, it is called cross Cannizzaro reaction. This reaction is quite useful for synthesizing a high yield of alcohol. As you can see in the image, benzaldehyde reacts with formaldehyde in presence of 30% NaOH and H3O plus is there, gives formic acid and benzyl alcohol. Another one is intramolecular Cannizzaro reaction. So intramolecular Cannizzaro reactions have been frequently studied as models for radicals or reactions occurring within an enzyme substrate complex. Although several intramolecular Cannizzaro reactions have been reported, only phenyl glycoxyl was or has been investigated with detail. So we will take here into account phenyl glycoxyl, right? So it will be converted to 1,2-hydride. So shift will be there, and after that proton transfer it will get converted into 2-hydroxy 2-phenyl acetate. So this is crossed Cannizzaro reaction. Now let's see uses and applications of Cannizzaro reaction in industry. So the combination of cross Cannizzaro reaction and aldol condensation is used in the industry to prepare polyols. Polyols are actually widely used and find many industrial applications. Neopentyl glycol is used in polyesters, for resins used in aeroplane or boat manufacturing, varnish coatings, synthetic lubricants and plasticizers. The neopentyl structure provides excellent resistance to light, heat and hydrolysis. Pentaerythritol, which is one of important product formed using this particular reaction, is a raw material in the varnish industry, while its tetranitrate is an explosive. Some esters of pentaerythritol is higher, or it is basically high fatty acids which are being used as oil additives, plasticizers and emulsifiers. Trimethylpropane, which is also one of the important examples, is used in several applications as glycerine substitute in alkyl resins, and they can also be used for preparation of polyesters and polyurethane.